This is TechPub's Mastering ASP.NET MVC 2.0 series. My name's Stephen Sanderson, and in this episode we're going to look at some of the most fundamental things you can do with controllers in ASP.NET MVC. Controllers and actions are the foundational building blocks for all ASP.NET MVC applications. So in this episode, we'll see how to receive incoming data and how to send data back to the browser in a variety of formats. First, let's establish what a controller really is and what it does. When the framework processes a request, it gets a URL, and from the URL, it knows the name of the controller being requested. In this example, the controller name is products. To process the request, the framework goes looking for a controller class matching that name. If it finds one, it asks that controller to handle the request. But if it doesn't, it sends a message back to the web server saying that it didn't handle the request, which usually means that the server will send a 404 not found back to the browser. But how does the framework find your controller classes? Well, at runtime, it scans your ASP.NET MVC project and all its referenced assemblies for all types that satisfy 4 criteria. 1. They have to be marked as public. 2. They have to be concrete, which means they're not abstract and they're not an interface. 3. They have to implement iController, which we'll come back to in a minute. And 4. Their name must end with controller. So in this example, the framework would go looking for a class called products controller. A lot of MVC developers misunderstand this point and think that the framework goes looking for controllers in a folder called controllers. It is conventional to keep controllers here, but after compilation, they're just types in a .NET assembly and they aren't in any folder at all. So the framework isn't looking in a particular folder, it's reflecting over all your referenced assemblies. You know that all controllers have to implement iController. Well, that's a really simple interface. All it says is that the type has to have an execute method which takes a context object describing the current HTTP request and does something with it. You can implement iController directly if you want to bypass most of the MVC framework and create a simple HTTP handler directly. But then you wouldn't be able to use most of the MVC framework's features, so it's more normal to derive your controllers from the framework's standard controller base class. This takes care of implementing the execute method for you, and adds a bunch of useful features such as actions and filters, which we'll come to in due course. It inherits from controller base, an intermediate base class that you can pretty much ignore because it's really only used internally by the framework, and that completes the picture by implementing iController. Alright, let's write some code. So for the rest of this session, we will be demonstrating controllers and actions by building up a little demo project called Job Ads, which will be a site where you can search for programming related jobs. So far, I've got a new ASP.NET MVC version 2 project, which is almost completely blank. It doesn't contain any controllers, which means that although I can build it, I can't run it. If I try to run it and open it in a web browser, I'll just get a 404 not found error. So I'm going to have to start by creating some controllers, and there are 2 ways to create a controller. The first is you can right click on controllers and go to the add controller menu option, and so I'll call this one jobs controller, and that will create a controller class for me which inherits from iController as we discussed before. But to show you there's nothing magic about that, I'm going to delete that controller and then I'll go back to add just a plain old C# class, and I will call it jobs controller, and I will manually make it inherit from the controller base class. And this is exactly the same result as we had before, so there's nothing magic about the menu item. Now I can run my new controller in the browser by going to the /jobs URL, but it still returns a 404 not found error, and that's because my controller doesn't have any actions. So I'll add an action. Actions are public methods on controllers and they can handle web requests. This one, index, returns a view result, which means that it renders a view. We'll talk more about these return types later. So we can run this action by going to the URL jobs/index, and if we do that, we still get an error, but it's different to the error we had before. We can see that it's trying to render a view and it just couldn't find one. When we rendered the view, we didn't tell it what name of view to render, so it will have used its built-in convention of looking for a view that was named after the controller and the action, so that's jobs/index, and it will look in a few different places, but ultimately it couldn't find one, so it gave up. To proceed then, let's create a view. which we can do by right clicking and going to add view, and we'll just leave these settings as they are. Let Visual Studio create a view for us, and I'll drop in some content I've already prepared there. And now we've actually got a real view. Once we rerun this action, we'll find that hopefully, yes, it actually does render a view. Okay, well, this episode is not really about views, but we're going to need a bit more view in order to proceed with the example. So I'm now rendering a search form from my view, and if you want to see what that does, I'll open up the search form partial, and inside there we can see that we are rendering an HTML form which will do render a text box into which the user can enter a query. They can submit the query, and when they do, the form will do a GET request to the jobs controller and to a method on it called search, which doesn't exist yet, but that doesn't stop us from having a form that references it. And now if I render that view, we'll see that comes up quite nicely, and hopefully then I can type into it. Let's say I'm looking for a Ruby job, and when I submit that, I get a 404 not found, and that's not completely surprising, because if we look at the URL that we've requested there, it's an action method called search, and as we noted before, there isn't any action method called search. So let's go back to the controller and add one, and it's just a simple matter of putting in another method, and we'll say that it will return a string this time, just to demonstrate the fact that you can return basic .NET types, and we'll take the query that the user has passed into us. So there's this convention that if your method takes parameters, then the framework will try to populate those parameters using data from the incoming request. And that's just a cleaner, simpler alternative to manually retrieving data from collections such as request.queryString or request.form. So we don't need to write that, we can just use the parameter. Great. Well, to actually run a query, we're going to have to start thinking about the application's domain model, which I already created earlier. Now, this is just a C# class library project which contains types that are relevant to the business domain of my application, which in this case is job advertisements. So I've got an entity class called jobAd, and that describes things like the title of a job, the salary and such like. And not surprisingly, I store them in a database, and in order to make those accessible to my application, I've got this repository interface there, and that exposes the ability to query for job ads, and specifically it gives a search method, so I can pass in a query term and it will return an enumerable collection of job ads. I've also got a concrete implementation of that which uses linked SQL to do the actual persistence, but I won't talk about that anymore because it's not really anything to do with ASP.NET MVC. So, back in my controller, I need to get an instance of that repository, so I'll just do that as a class level field, and then once I've got that instance, I can run a search using the query that the user has supplied, and I'll get that data, and I can just return a string from my method, and I'll return the number of results. And if you return a string from an action method, the MVC framework will just display that string in the browser. So hopefully now, if I rerun this method, I should see that yes, there were 67 matches for Ruby as a keyword, and I can change that keyword. Let's try something else, and yep, 51 results there. Or I could try searching for, say, a place, USA, 265 results. Brilliant. Before we get lost in the details of the job ads application, let's take a step back, recap the concepts we've covered, and get an overview of what's left to learn about controllers and actions in this episode. So far, you've learned that controllers are just .NET classes that satisfy certain criteria, whether or not they're in a folder called controllers, and that each of their public methods is called an action, and it can be invoked from the web on some URL. This is quite different to web forms, where each page is a separate file on your server's disk. Next, you know that in Model View Controller architecture, controllers can choose to display a user interface by rendering a view, and you probably know that the controller chooses what data should appear by passing some model object to the view. Let's see that in action now, and also discuss a good practice you can follow called view models. Now back in the job ads application, we've got to the stage of displaying the number of results, but of course what we actually want to do is to render a view giving the full details of all the job adverts that have been found. We want to change the search method so that instead of returning a string, it returns a view, and we can declare that by returning a view result. And then we change the return value so that it says return view, and that's an instruction to return a view, and we can pass some data to that as a parameter to that method. So we'll send all of the results from the repository to the view. Now we need to add a view for that, so I'll add one, and I can give the name of the type that we're going to be rendering, and that gives us IntelliSense in the view. So we're going to be rendering an enumerable collection of job ads as our model. Add the view. I'll just tidy that up slightly. And now we can use this data that we've been given by the controller to render some useful data. So I'll render all of the job ads as an HTML unordered list by writing a for each loop that iterates over all the job ads in the enumerable model and displays the job ads title. And I'll try running that now. So I'll search for C# jobs this time. And yes, that works. We've got an HTML unordered list of job titles. But what if I wanted to send more data to the view than just that one list of job ads? For example, I might have a page list and I want to send the current page number. Well, let's go back to the controller and see how we could do that. If we want to add any arbitrary collection of additional information, we can add it to a dictionary called view data. We just choose some key and assign some value to it, and then that data becomes available in the view. Let's try it out then. Switching back to the view, we'll try to get the data item that we just put into view data. As long as we use the same key name, we should get the value. Let's switch to a browser and try that out. And yes, the page number of 1 has come through. So that's nice. We can pass any collection of data from the controller to the view using view data as a dictionary. But there are some disadvantages. So when I'm writing my view, I don't get any IntelliSense to help me pick out the items from view data. There's no way of knowing what data will be under any key, what type it will be, or if there will be any data. We'll consider a different approach in a minute, but for now I do recommend that if you are going to use view data as a dictionary, you create some strongly typed wrapper class that gives you a set of keys that you know are the actual standard ones. So for example, you can create an enumeration, I'll call it view data keys, put a bunch of standard keys in there, and then instead of using magic strings when I'm putting data into my dictionary, I can reference items on my enumeration. So in this case, view data keys dot search results page index. And of course I can reference the same key in my view. I have to import a namespace though, so it's looking a bit verbose and clumsy, so maybe there's a better way of doing all of this. And this brings us on to the idea of view models. The idea is that instead of controllers supplying to the views just a domain model object, such as a job ad or a collection of job ads, which may not have all the information that the view needs, and instead of using view data dictionary in a loosely typed kind of way, we can instead create a class which is specific to our view and simply describes all the information that the view will need to render. This class is called a view model. So let's create one for the search action. Just simply create a new C# class, and because it's for the search results, we'll call it a search results view model. And then we can put into there all of the information that the view is going to need to render. Now I already know what that's going to be, so I'm just going to drop these properties in. And if you're interested in what the paging info is, well, that's a reusable class that describes information about paging, so which page you're on, how many pages there are in total, and the indexes of items at different positions in the paging set. Now that's done, we can change the way that the search action returns data. Instead of simply returning the results, we'll return an instance of search results view model, and we'll use the C#3 collection initializer syntax to set up all the different properties on there, so we can send the results along and other information like the query that the user had run, and we're not really using paging info yet, but we'll just set it up to show that it can be done. Now we've made that change, if we try running the application, we'll get an error message. And that's because we have told the view previously that we were going to send it an enumerable of job ads, but now we're sending it a search results view model, and it doesn't really know what to do with that. So we better update the view. If we go into the view, we'll find the inherits declaration right at the top of the view there, and we can see that it's still got its old value there, so we'll change it to inherit from view page of search results view model. That defines the type of data that the view expects. And now that's done, we can get rid of a lot of this really nasty syntax. So instead of that view data dictionary there, we shall be able to get rid of that and pick out a property from our model which has got all the ideal properties that we want to render in this view, and it's still easy to access the results. So that's altogether a lot cleaner and tidier, and if we run that in the browser now, hopefully it will still work. Yes, it does. Very good. That's the view model pattern. Okay, getting back to the application, we're about to work on adding a page parameter, but before we get to that, I just want to show you how I've added a bit of visual style to the application. So previously what we had was this page that you're seeing now, but if I refresh that, you see it looks a little nicer now. There we go, so it's got a bit of nice styling, although it's displaying some slightly strange information here. And the reason all this is happening, if we switch back to the view, is that I've changed the view a bit. I haven't changed the controllers at all. I've just been into the view and made it display a block with information about the results and the number of items, displaying a proper HTML table for the actual job ad data, and then at the bottom we're rendering some page links. Now, having all this into one view is probably making that view a little bit overcomplicated, but this episode is not about views, so I'm not going to worry about factoring that down into partials and such like. I'm just going to leave it in one place to make it more easily understood. But you should understand that I haven't changed the controller at all, which is the thing that we're really interested in. Right, switching back to the jobs controller, the first thing we're going to want to do is deal with the slight strangeness of the fact that it's displaying this information for page number, and that's because we're not passing any page information to the view right now. So I will add that. Firstly, we'll want to declare the number of items on each page. Let's have 8. And when we send in our information to the view, our link iQueryable data that we get back from the model, we can say that we only want to take a certain number of items from that. And then we can supply full paging information. And with that done, if I compile and rerun, we'll be passing all of that information to the view. It's now displaying just the first page of the C# results there, and I could try searching for something else. Say I want to work somewhere slightly warmer than Bristol, UK. Okay, that's great. But what happens if I try to change page? I'll try to go to page 2, and I did click on that, but it's still displaying the first page. And if we look at the URL, we'll see that we do have a page equals 2 query string parameter, but it's being ignored. And that's because we haven't added any code to the controller to actually do anything with such a parameter. So as I mentioned earlier, if you want to receive an input parameter, which might come from a query string or a form post, then you can simply declare that as a method parameter. As long as the name of the method parameter matches the name of the query string value or the form value, it will all get matched up appropriately. And this is a very simple example of something called model binding, which we'll cover in much more detail in a different episode. And there we'll be talking about how you can bind arbitrarily complex custom .NET objects and how you can add your own custom model binding mechanisms if you want to. But for now, we're just working with primitive data types. So now that we've got the page number that's been requested, we can pick out that particular page of data with a bit of a link query and pass the paging information to the view. So now I'll switch back to the application, and hopefully this time if we reload the page 2, we do in fact get page 2 correctly. And now I can switch between pages and everything's working properly. But let's try running this query again from scratch and see what happens. I've now got an error message. The MVC framework knows that we've asked for a page parameter in our action method, but what value should it supply? There wasn't any value that came with the request. It would try to supply null if it could, but an int can't accept a null, so it just has to throw an error and give up. So what we'll have to do is define a default value for that parameter. If I was using C#4, I could use the C#4 default parameter syntax, like that, to define that the default page should be 1 if not specified. But since I'm not using C#4 here, I'm in Visual Studio 2008, I'll use a new attribute that's been included in ASP.NET MVC version 2, default value, which has exactly the same effect. So now I'll recompile and re-request that URL that doesn't include a page parameter. And as you can see, it takes 1 by default. So that's how your action method can take multiple parameters of different types and even specify default values. When you want to return some output from your action method, the usual way to do it is to return an object of type actionResult. To understand this concept, let's consider the alternative. If you had an action method that wants to write some HTML out to the browser, one way that you can do that is just to call response.write directly from the action. You could also set response headers or write arbitrary binary data to the response stream if you wanted. But there'd be some disadvantages to doing this. One is that you'd have to remember exactly what combination of response headers and response.write calls produce the output that you were trying to accomplish. The other is to do with testability. If you were writing a unit test for this action, you might have to mock the response stream and parse the HTML to check that it was including the right data. So the MVC framework has this notion of action results, and the idea is that instead of sending output directly from your action method, you instead return an object that describes your intention for what you want the framework to do on your behalf. Action result itself is a very simple abstract base class. All it says is that it can be executed in some way, and what that means depends on the subclass you choose. The framework comes with a range of built-in action results for common web development scenarios. So for example, to return a binary file, you don't actually call response.transmitFile like you might do in web forms, but instead you return a file result which describes the location of the file on disk that you want to send to the browser. You then get the twin benefits that the MVC framework knows how to correctly send that to the browser with all the correct response headers, and also your action method remains testable because a unit test could simply observe the file result coming back from the action and verify that it was pointing to the correct file on disk. You've already seen how you can return a view result to describe an instruction to render a view, and in the rest of this episode we'll consider the other most commonly used action results, with the exception of JSON result, which we'll save for the episode about Ajax. To let the user download more information about each job, there'll need to be some sort of button or link that will let the user do that. So let's add a new column to this table. It will appear on the right and it will have a link in it for each job that provides more information about that job. So back in my view, I'll add a new table cell to the table. And as you can see, all it contains is an HTML link to an action called download job details, which doesn't exist yet, and it tries to pass the job ad ID of the current row to that action. I'll run that. And now we've got our download links, and each of them has a different query string parameter. I'll click one of them, and of course we'll get a 404 not found because there is no such action just yet. Let's add a new action that will transmit a binary file to the user. It will receive the job ad ID as a query string parameter and return a file result, which is the MVC framework's built-in action result for transmitting binary files. To construct a file result, I simply say return file. And now, depending on which overload I choose, I can either transmit the contents of a byte array that I've already got in memory, the contents of a file on disk by passing the file name, or transmit the contents of an existing stream by passing a file stream handle. But first, I'll use the incoming parameter to load the correct job ad entity from the database. Here you can see I've used a simple link query to fetch the first job ad whose ID matches the incoming parameter. And now, using that ad, I'll call the overload of file that takes a file name, passing the file name that I get back from my domain model. I also have to specify the content type of this binary file, and the browser will use this to decide how to treat the file, whether it should display it online or whether it should open it in some external program. In this case, I'll specify that it's a PDF file. And optionally, I can also cause the browser's Save or Open pop-up to appear and suggest a file name that the browser should prompt the user to save the file as. I'll just tidy that up slightly. So I've specified the file name on the server's hard disk, the MIME type that tells the browser how to treat the file, and also a suggested file name for the user to save the file as on their own disk. Now this is done, I'll go back to the application and try clicking one of those download links. And as you can see, the browser's received the file, it knows that it's a PDF file, and it's got the suggested file name for the user to save it, or open it in their chosen PDF viewer. So that's how to send binary files to the browser. Now another thing you can do with an action result is control which users are authorized to perform certain actions. Normally the way to control authorization in ASP.NET MVC is to use a filter called Authorize, and we'll cover that in a different episode. But the Authorize filter is only good for controlling who is able to access an entire action, and isn't very good for controlling who's able to access a certain code path within an action. And for that we can use an action result called HTTP Unauthorized result. Let's say in this example that the download details for certain job ads are restricted to logged in users. I can implement that logic very easily. I'll just say that if this ad is one of the restricted ones, and if the current user isn't logged in, then the user shouldn't be allowed to see this ad, so I'll return a new HTTP Unauthorized result. Since this action method now returns multiple types of action results, I'll need to specify its return type as the generic base class action result. So what will this actually do? Well, let's try and find out. I happen to know that the test programmer job is not restricted to logged in users, so when I click this details button, I'll be allowed to download the full details. But I also happen to know that the Visual Basic Programmer job is restricted, so since I'm not logged in, I shouldn't be allowed to download the PDF. So now we're returning an HTTP Unauthorized result, and this causes your active authentication mechanism to kick in. Now in my web config I've got it configured to use forms authentication, and I've specified that the logon URL is account/logon. In fact that's the default value. So the framework's done a redirection to that URL so that the user can log on. I haven't actually implemented a logon screen, so there's just a 404 error, but that's irrelevant for this demo. We've just demonstrated that by returning an HTTP unauthorized result, the framework will deny access to the user and invoke your active authentication mechanism so the user can log on. Now you know HTML is a text-based data format, but of course there are other text-based data formats too, such as XML, RSS, JSON, and of course plain text. And if you want to send these to a browser, you can use a content result. For the job ads application, let's say we want to let the user subscribe to an RSS feed of results matching an arbitrary search. Here in my view, I've added a link to an action called feed, which doesn't exist yet, and we're passing the user's search query as a parameter. To make this work, let's add a feed action which returns a content result. First, we need to generate the RSS feed data, and we'll get it as an XML document. Now I've already made a utility class that takes an enumerable of job ads and makes an XML document containing that data. And in case you're interested, here's the code for that. I'm only showing it just so that you can see there's not very much code here, but I don't really want to dwell on this because it isn't actually anything to do with ASP.NET MVC. So let's just accept that that works, and we'll switch back to the controller, and we can now return a content result, passing that XML data as a string. Great, so let's see this in a browser. I click the RSS link, and that's not quite right. It's the right data, but it's coming out as plain text, and that's because the browser doesn't realize that it's supposed to be RSS data. And the reason for that is because content result by default instructs the browser to treat the response as plain text by sending a MIME type of text/plain. We can change this by going back to our code and modifying the content call to specify a different MIME type. The standard MIME type for an RSS feed is application/RSS plus XML, so let's use that. And now we've specified that, we'll try running it again. And there you go, we can see the browser is now correctly treating and formatting it as an RSS feed. That was pretty easy. To illustrate the idea of redirections, let's imagine that we want to keep the user within a valid range of pages for their given query. So for the current query, for example, the user's on page 3, but they could directly type in a different page index if they wanted, page 300, and that produces a slightly strange result. It's a bit nonsensical, so what we might decide is that if the user tries to access a page that's outside a valid range, we should redirect them back to page 1. To implement this, let's first refactor this search method very slightly by capturing the search results view model as a variable. And then to retain the existing behavior, we'll pass that to the view method to return a view as before. Now that hasn't changed the existing behaviour, but it puts us in a position to catch invalid page indexes and do something about them. We'll say that if a user has requested a page index that's less than 1, or is more than the total number of pages that exist for this query, then it's an invalid page and we need to send the user back to a valid page index. To do that, we can issue a redirection. In this case, it will be from the search action back to the search action, but using a different parameter. To issue a redirection, we can call return redirect to action, and that takes the name of the action that we're redirecting to, and it lets us pass an arbitrary collection of additional parameters to that action. The syntax is slightly strange because it takes a C#3 anonymously typed variable, and then it will use reflection over that object to pick out the parameters and values that you're passing. We'll retain the user's query, but we'll force them onto page 1. And once again, we've now got an action that returns multiple types of action results, so we'll declare the method return type as the base type action result. And with this logic in place, if we try to reload page 300, we'll find that the user has correctly been redirected back to page 1. That's great, but it's slightly confusing for the user because they might not realize why they've been redirected to page 1. So this brings up an opportunity to illustrate the idea of temp data. When you perform a redirection, you might want to maintain some temporary state data across that redirection. And for that purpose, the MVC framework provides a dictionary called Temp Data. We can put any arbitrary key value pair into temp data and it will be preserved across the HTTP redirection. In this case, we'll use it to put a message that will tell the user why they were redirected. Temp data is not only for displaying status messages, but it is commonly used for that purpose. Now, just because I've put some data into temp data doesn't mean it will be displayed to the user, but it does happen that in my site's master page, I am looking for an entry in temp data called message, which I'll display in a special format. So let's try running this again. I'll enter an invalid page number, and the message appears. And because the contents of temp data is only preserved until the first request on which it's actually read out, if I was to reload this page, page 1 again, you'll see that the message is not there anymore, which is perfectly good in this case because we only wanted to preserve the data across the HTTP redirection. We didn't want to preserve it indefinitely. So there you go. You've now seen most of the basic stuff that controllers and actions can do, but there's loads more to the MVC framework. So in the Controllers Part 2 episode, we'll investigate some of the more powerful and advanced features, such as custom controller factories and asynchronous controllers. Thank you very much for watching.